back to Maths with Mrs. J. I'm going to do a series of videos about ratio and rate. To start with, I wanted to just do some simple examples of ratios and how we simplify those. A ratio is when you compare quantities of the same kind. So you might be saying that the ratio of girls to boys in a class is 10 to 11, or the ratio of length to width of a room is 4 to 3 or something like that. We do talk about ratio in terms of televisions. We talk about length to width being 16 to 9 these days, that sort of thing. Now, to simplify, it's almost identical to the process of simplifying fractions. If we have something like 18 to 24, what we want to do is we want to find the biggest common factor of both and divide them both by that. The biggest common factor is 6, so we're going to get 3 is to 4. If you didn't come upon 6 to start with and say you divided both by 2, you would have got 9 to 12. That's okay as long as you keep going and then divide by 3 and get to 3 is to 4. It doesn't matter if it takes you a couple of steps to get there, as long as you don't stop until there are no further common factors. When we have decimals involved, what we want to do is we want to multiply both sides by whatever we need to multiply by to get rid of the fact that there are decimals. In order to get rid of this decimal, I need to multiply that side by 100, and that gives me 1. I can't just do that to the left-hand side. I have to do it to the right-hand side, so I get 1 is to 500. If we have different units, like we've got in examples 3 and 4, our first step is to change to the same units. And because we don't want decimals, normally you'll change the bigger unit into smaller units. So 1 metre is 100 centimetres. Once you've got the same units, you can then simplify. 25 goes into 25 once, 25 goes into 100 4 times. So you must have them in the same units in order to drop those units. Same thing here. We don't really want to change this into kilograms by doing 3.2 because then we're going to have to get rid of the fact that we've got decimals. So if we change both sides into grams, then we can in essence get rid of the grams and we can divide both sides by 100 before we even start thinking about anything else. Then we've got 32 to 40. What can go into 32 and can also go into 40? Well, 8 will go in 4 times into 32 and 5 times into 40. If you divided by 4 first, that's fine. You would have got 8 is to 10, as long as you then keep going until you get it into simplest form. When you have fractions, there are 2 main ways of doing it. You could multiply both sides by the lowest common multiple. I'll show you that way. So let's say we multiply, so 3 and 4, the smallest number that they will both divide into is 12. So if I do that to both sides and then cancel, I'm left with 4 times 2 and 3 times 3, which is 8 is to 9. That's perfectly fine to do it that way. And in fact, that's how, if I had an equation involving fractions, I would tend to go that way, multiply every term by the lowest common denominator. The other possibility of doing this is to say, okay, well, let's put them both over the same denominator. So they're both going to be over 12. I've multiplied that by 4, so I multiplied that by 4. I've multiplied that by 3, so I've got to multiply that by 3. Then you can, in essence, drop the denominators by multiplying both sides. They are equivalent methods in reality. Whichever one you want to use is fine by me. if you have mixed numbers, the first thing you need to do is put them as improper fractions, and then you proceed as you would in example 5. 1 times 5 is 5, plus 4 is 9. So 9 on 5 to 2 times 4 is 8, plus 1 is 9. 9 on 4. Okay, several options here. Let's put them both over. Well, I would be inclined actually at this stage to divide both sides by 9, just to make our lives a bit easier. Why deal with bigger numbers than you have to deal with? You can divide both sides by 9. Now put them both as something over 20. So this will be 4 on 20 and 5 on 20. So we get 4 is to 5.